Hello everyone, welcome to Study IQ. So in this video we will continue our discussion on speed distance time. Okay, so we have completed 5 sets already. So 5 sessions are completed with respect to time and distance. Okay, so this is our sixth video. Okay, so in this session I'll be talking about boards and streams and also the clocks. Okay, so clock we basically consider it as a race. Okay, like minute hand and hour hand is moving together, so in a circular track. So already the questions related to circular track we have discussed yesterday or in the previous session. So I will relate it to the same thing only here. So I'll take the last 5 minutes to explain clocks related questions. Okay, so we will focus on boards and streams because you used to get a lot of questions not only from CAT. You will get this questions in other papers also. If you take bank exam or SSC or anywhere, you will expect questions from boards and streams. Okay, so see, the very simple point that you need to understand is, again, boards and stream questions are based on relative speed that we have learned in detail in our set 3 of speed distance time. Okay, so here 2 points that you need to remember here is, see, a boat, okay, or any body, if you are swimming, instead of boat it can be you are swimming. Okay, it can be against the stream and towards the stream, or opposite to the stream and the same direction of the stream, or whatever it is. Okay, so one speed is either your speed or the speed of the boat or the speed of the floating body or whatever it is. Okay, so let me take it as speed of the boat. Apart from speed of the stream, what is there? If there is a speed of the boat or speed of the person, it will be given. Okay, speed of the boat, okay, is SB. Let me mark it as SB. Okay, and speed of the stream, let me mark it as SS. Okay, so speed of the boat and speed of the stream is known to you. Okay, so in still water, okay, that means there is no impact or effect of the stream. What will be the speed in which you can row? It will be speed of the boat. There is no other influence. Okay, so speed of the boat is given as 10 km per hour, means in still water you will move at 10 km per hour. Okay, but if you are moving towards the stream, if you are moving opposite to the stream, okay, if you are moving against the stream, or you will say upstream, okay, if you are moving upstream, the upstream speed is given as, what is the relative speed? Okay, it is speed of the boat minus speed of the stream. Now keep in mind, here you are moving opposite direction, and you should not have any confusion when we discussed about the case of train. When you are moving in opposite direction, we are in fact adding, right? Here we are subtracting. So opposite direction, I hope you understood here. Your speed will actually reduce because of the impact of the stream. That's why minus. Okay, so when you are moving against the stream, the speed coming down because of the impact of the stream, so the speed is less. When you are moving towards the stream, when you are moving along with the stream, okay, when you are going downstream, that means with the stream, okay, downstream, your speed will increase again because of the influence of the stream. Okay, so here speed of the boat plus speed of the stream. Okay, so these are the 2 points. Upstream speed is speed of the boat minus speed of the stream. Downstream speed is speed of the speed of the boat plus speed of the stream. Okay, so now if you mark this as A and this as B, okay, so A is the upstream speed and B is the downstream speed. So if these two are given, you know upstream speed and downstream speed, but that will not make any question. Okay, that we'll discuss the question type also. Now another scenario is the upstream speed A is given and B is given. Then you will be asked to find out speed of the boat or speed of the stream. Okay, so this can also be a question. So in this case, what is the speed of the boat? If upstream speed is known, that is A, and downstream speed, that is B divided by 2. Okay, then what is the speed of the stream? Upstream speed A minus downstream speed B divided by 2. So these are the 2 points that you need to remember. This is one less, so SB minus SS. Downstream speed will be more, so SB plus SS. Now if upstream speed and downstream speed is given, then speed of the boat and speed of the stream can be found by using this. Okay, so I hope this is clear for you. Now let me give you a very simple example question. Okay, see, a person rows a boat at the speed of 15 km per hour. Okay, so 15 km per hour upstream and 20 km per hour downstream. Okay, so what is given is upstream speed is given and downstream speed is given. So you can expect a question, what is the speed of the boat in still water? or what is the speed of the stream? Whatever it is, you can answer, right? Because we have already told you if this is A and this is B, speed of the boat is A plus B divided by 2. Speed of the stream is A minus B divided by 2. Okay, so here upstream speed is given and downstream speed is given. So what will be the speed of the boat? Speed of the boat will be 20 plus 15 divided by 2. That means 35 divided by 2. So what about the speed of the stream? 20 minus 15 divided by 2, that is 5 by 2 kilometer per hour. This is also kilometer per hour. So I hope you understood this also. Okay, if speed of the if upstream speed and downstream speed is given, you can find speed of the boat and speed of the stream. Okay, now one more question if you want. Now rather than boat, they will tell you a stationary body. Okay, so there is a stationary body which is floating in a river. Okay, so stationary body means that doesn't have any speed. Okay, so there is a body floating in the river. Okay, now I'll give you the speed of the river. Okay, so speed of the stream will be given. It's like 5 kilometer per hour or 10 kilometer per hour or whatever it is. Okay, so 5 or 10 kilometer per hour. Okay, so it depends. Now a stationary body, okay, so that means no speed obviously. So this is actually floating in the river. So I can tell you how much time this floating body will take to reach at a point which is kept 10 kilometer away from this point. Okay, or 20 kilometer away from this point. Okay, so a body is floating in the river, so this speed of the river is given and how much time this floating body will take to reach at a point which is 20 kilometer away from the present location or 10 kilometer away from the present location. I hope you understood the question. Okay, so then what is your speed here? Only one speed is there. Let's forget about the speed. Only one speed is there. There is no concept of relative speed because this floating body don't have any speed. Okay, or the person is not swimming, just lying down. If it is a person who is floating in the river, then still he is not swimming, he is just lying down. Okay, so 5 kilometer per hour is the speed of the stream. So what is the distance you need to cover? I told you 10 kilometer away. So what will be the time taken as the question? Time is distance by speed. So distance here is 10 kilometer. Speed here is speed of the stream because the other object, the stationary body or the person don't have any speed. Okay, so that is 5. So how much time it will take? 2 hours. I hope this is clear for you. Now one more type of question is, see the speed of the boat in still water. When I say speed of the boat means I am talking about speed of the boat in still water. Okay, so that is given like 10 kilometer per hour. Okay, so speed of the boat in still water is given as 10 kilometer per hour, and with this boat you are going for a boating or something. Okay, so you are moving to the river, so with the speed of the stream. Okay, so the speed of the stream is not given. So what you know is speed of the boat is known, speed of the stream is not given. So that may be the question. Okay, now what else is given is upstream speed is not given. If upstream speed is given, we can find the speed of the stream because upstream is actually SB minus SS, and downstream speed, if it is given, it is easy. But instead of speed, what they have given is upstream. If you are moving upstream, the time taken to reach a distance is given. Okay, so that is 2 hours. And downstream, if the same distance, obviously there is an impact of stream, the speed is more, so time taken will be less, so 1.5 hours. Okay, so this is what given. So if you look at this question, speed of the boat is given, upstream time taken is given, downstream time taken is given, speed of the stream is what they are asking. So this is a moderate question. Okay, now here how will you solve this question? Upstream time is given, downstream time is given, speed of the boat is given. One more important point which you need to note here is distance is constant here. That is also given. Okay, because same if you are moving upstream and downstream, you are actually covering the same distance. Now see the property that we have learned, if distance is constant, what about the relation between speed and time? Speed and time is inversely proportional, right? So if distance is constant, speed and time is inversely proportional. Now what you know is the time ratio, you know, that is 2:, or this you know 2 and 1.5. Okay, so you can write it as 4:3. So this is what the time ratio. So what will be the speed ratio? This is the time ratio. So what will be the speed ratio? 3:4. So the speed ratio will be 3:4. Now speed ratio means I am talking about upstream and downstream ratio. So upstream ratio means 3 downstream means 4, like that, right? So if you take upstream, downstream, it is 3:4. That's the ratio. Now from here what we know is speed of the boat, we know speed of the stream is what we need to find out. Let's assume that this is x. Okay, let's assume that this is x. So what is upstream speed? Upstream speed will be 10 minus x. Okay, so upstream speed will be 10 minus x. Downstream speed will be 10 plus x. So what we know now, you know this ratio. So now you can write this as 10 plus x divided by 10 minus x is equal to 4 divided by 3. Now this will become, how will you write? 40 minus 4x is equal to 30 plus 3x, right? So now this 4 will go here, so that will become plus. So you can see 7x is equal to, when 30 comes here, that's minus, that is 10. Okay, so x is equal to 10 by 7. So what is the speed of the river? 10 by 7 kilometer per hour. So the speed of the stream is actually 10 by 7 kilometer per hour. So I hope you understood this. What is given in this question is speed of the boat is given, upstream time taken is given, downstream time taken is given, speed of the stream is what you need to find out. We know the distance is constant. From that we understood that if the time is given, we can find the speed ratio. Because if distance is constant, speed and time is inversely proportional. So once we know the time, we know the speed ratio. And speed we can write as 10 minus x and 10 plus x. If we assume that the speed of the stream is x and x is what we need to find out. So 10 plus x divided by 10 minus x we can write as 4 by 3. From that we can find the value of x and we got it as 10 by 7 kilometer per hour. And that's the speed of the stream. So this is a key point, speed of the boat, speed of the stream. Okay, so still water, the speed of the boat only, there is no impact of the stream. Now there is a stream, but the body is not moving. If there is no speed for the body, okay, so that means floating body that we have discussed previous case, only speed of the stream. Okay, then the question will be time taken for this body to reach at that point, or time taken for this boat to reach at that point. Then this is a very simple question. Next is where the relative speed is applied, right? Upstream speed we have seen, it will be less, so speed of the boat minus speed of the stream, there is an impact of the stream. Downstream speed, speed of the boat plus speed of the stream. Then we have seen, if speed of the boat, which is, if upstream speed that is a and downstream speed that is b is given, then speed of the boat is actually a plus b by 2, speed of the stream is actually a minus b divided by 2. So these are the things that we have learned so far. Okay, now that's about boats and streams. There is nothing much to discuss. Everything you can solve by using this concept that we have learned. Now let's move on to clocks. Now questions related to clock is basically based on the movement of minute hand and hour hand, and also the relative movement of minute hand and hour hand. So obviously this relative speed concept is applied. Okay, but in this case, see here, so we are going to solve this as considering as a circular track. Okay, when we discussed about the questions based on circular track, we have discussed about two types, moving in the same direction and moving in the opposite direction. So here, moving in the same direction is what applied, not moving the opposite direction. So when you are moving in the same direction, we know the relative speed, right? So S1 minus S2. So if minute hand is having a speed of S1 and hour hand is having a speed of S2, the relative speed will be S1 minus S2 always. Now, what you need to do is consider this as a track, circular track with 60 kilometer as the distance. Okay, 60 kilometer as the distance, and every minute, each minute is actually 1 kilometer. Every minute is actually 1 kilometer. Now if you look at that, what is the speed of the minute hand then? 60 kilometer per hour. Okay, 60 kilometer per hour is the speed of the minute hand. Why? Because it is actually covering that 60 distance, one revolution, okay, in 1 hour. And if we consider the circular track, the clock as a circular track with the distance 60 kilometer, the speed of the minute hand can be understood as 60 kilometer per hour. Similarly, what about the speed of the hour hand? That will be 5 kilometer per hour. Then what is the relative speed? That will be 55 kilometer per hour, 60 minus 5. Okay, so the relative speed between the minute hand and the hour hand will be 55 kilometer per hour. Now this is a concept that you need to know. After this you can solve any clocks and clocks related question, and this is similar to the race question, right? So here minute hand and hour hand is moving together. Okay, so the speed is different. minute hand is moving faster, so the relative speed is what we need to consider. So the question can be about anything. You can find the answer by knowing this. Okay, so 60 km per hour is the speed of the minute hand, 5 km is the hour hand, 55 km per hour is the relative speed, and this is fixed. Okay, now the total distance is 60 km, and every minute hand is covering 1 kilometer. That means 60 km per hour. That's the idea. Okay, apart from this, some other standard questions like how many right angles are formed in 1 hour. Now the questions like how many right angles, etc. So the clock will actually make 2 right angles in any 2 hours. Okay, so it's like 12 to 1. If you see 2 right angles and 1 to 2, 3 to 4, 5 to 6 like that, the clock will make 2 right angles. Okay, but one point that you need to remember is in 24 hour, if I ask you how many right angles, see I told you 2 right angles in every 2 hour like this, any 2 hours. So 24 hour it's not 48. You may calculate like 2 into 24, 48. Okay, it's not 48. The reason is, see the time period between 2 to 4 and 8 to 10, see it's not actually 4 right angles, it's only 3 right angles are formed. Okay, so during this time 2 to 4 and 8 to 10 you can see only 3 right angles. So what we have discussed is any 2 are 2 right angle, but here you are expected to get 4 right angle, but you are getting 3 right angles only. The reason is the second right angle that you're supposed to get between 2 and 3 or 8, 9, and the first right angle of 3 to 4 or 9 to 10 is actually same. So the second right angle that you're supposed to get between 2 and 3 and the first right angle that you're supposed to get between 3 and 4 is the same. What is that? 3. Similarly, the second right angle that you're supposed to get at 8 to 9 and the first right angle that you're supposed to get in between 9 and 10 is same. What is that? 9. So I hope you understood what is that right angle when it comes to 3. So this is 12, this is 3. So this is a right angle, this is a second right angle between 2 to 3. And there is a first right angle between 3 to 4 also. So this is coinciding. Similarly, this one 9, 12. So this is happening at 9 o'clock, and that's the second right angle between 8 to 9 and the first right angle between 9 to 10. These two are coinciding. So instead of 4, you are actually getting 3 only here. And so you cannot get 48 right angles to total in 24 hours. So you need to subtract 2. Okay. So that's how you get the answer. So I hope this concept is clear. Any 2 hours you will get 2 right angles, except in this case. Okay, 2 to 3 and 3 to 4, that is coinciding 3, so that you need to subtract. Again 8 to 9 and 9 to 10, that is a coinciding. Okay, same is the case with straight line also. Now see, when you are getting a right angle, the minute hand and hour hand will have an exact difference of 15 minutes. Okay, so when the minute hand and the hour hand is having a distance of 15, you will get right angle. Now same is the case with the straight lines also. You will get 2 straight lines in every 1 hour. Okay, so this is one straight line, and this like this also one straight line. So if you see, now if I ask you how many straight lines in 24 hours, you are expected to get 48, right? But the problem that we have discussed in case of right angles is applicable here also. When it comes to straight line also, that situations will come. During what time? See, one case is 5 to 6. 5 to 6, one straight line that you are expected to get is 6. Okay, like this. So 6 and 12. And similarly, 6 to 7. So the second straight line that you are supposed to get at 5 to 6 and the first straight line that you are expected to get at 6 to 7 are actually the same. This is the one. So here there is a coincidence. So instead of 4, you will find only 3 straight lines, like we have seen in the case of right angles. So when we talk about right angles, I am talking about 2 to 3 and 3 to 4 and 8 to 9 and 9 to 10 time. Okay, so this is the exception. So here when I talk about straight line 5 to 6, so you can get a straight line at 6. Okay, so that is a second right angle during this time, this hour. Then during this hour, the same itself is the first straight line that you are expecting. Both are coinciding, so you need to subtract that. Okay, so if I ask you 5 to 7 how many straight lines, it is actually 3. Okay, otherwise if I simply ask you 3 to 5 how many, you'll get 4. Okay, so here is what you need to take care, because based on this only you will get question. So similarly, if the question is about 2 to 4 how many right angles, it is 3 only. Similarly 8 to 10, it is 3 only. But otherwise if you take any 2 hours, you'll get 4. Okay, so exception is these two. And again, when it comes to straight line, not only 5 to 7 time, okay, you can get this between 11 to 1 also. How? Because 11 to 12, what is the second straight line? That is actually 12 o'clock, like this. This is one straight line. Both minute hand and hour hand will be straight line. Okay, then again, 12 to 1 time, if you take the first right angle, you are supposed to get is the same only. So here also you can see coincidence. Now the point is, what I need to conclude is by saying right angles and straight lines is what I have discussed. Okay, so in every 1 hour you will get 2 right angles, 2 straight lines, no confusion. So you take 2 hours together, it is 4 and 4. Okay, so what we have discussed is about right angles and straight lines, right? So generally every 1 hour, every hour you will get 2 straight lines and 2 right angles. Okay, every 2 hour then 4 right angles and 4 straight lines. But the exception is, see, if the question is about, so we were actually talking about right angles and straight lines in the clock. Okay, I told you every hour you will get 2 right angles and 2 straight lines. But if you take 24 hour, you won't get it. Okay, the reason is, see, between 2 to 4 there is a problem, right? What is the problem? We have already seen at 3 o'clock. Okay, so 2 to 3 if you take the second right angle is expected to get at 3, and 3 to 4 if you take the first right angle is expected to get at 3. So this is coinciding. Similarly, 8 to 9, the first right angle is expected to get at 9, the second right angle is expected to get at 9, and 9 to 10, the first right angle is expected to get at 9. Okay, so this is coinciding. So these two you need to subtract. Similar